So I'm Liz Rogers. I'm not Ron, but I will be starting us off today. So first, I want to say thank you to the Urban Forest Connections team for this opportunity for all of us to share our work with you today. And thank you to Max for working with us. It's been a pleasure. And yeah, thank you all. And we look forward to discussing innovative approaches to establishing trees in harsh environments with you. And so next slide, please. Before we go any further in terms of establishment techniques, it might be helpful to first define what exactly is a harsh environment. What do we mean when we say that? And for me, if I asked you to picture a harsh environment or harsh conditions, I'm not sure if that would really bring to mind a certain site or certain conditions. So another way to think about this would be to define harsh environments as the opposite of optimal environments. So those environments that have the opposite of optimal conditions. So optimal conditions for tree growth, tree health, tree development would be optimal amounts of light, optimal amounts of water, carbon dioxide, as well as optimal amounts of nutrients, all of which are necessary for photosynthesis. And we could dive further into that. We don't just need light, water, carbon dioxide for photosynthesis, but we also need chlorophyll within plants. And for chlorophyll to be synthesized, we need proper nutrients such as nitrogen, magnesium, iron, sulfur, and plants get these nutrients from the soil. So in an optimal environment, there not only are optimal amounts of nutrients for plants to be able to synthesize chlorophyll, but these nutrients need to be available to plants within the soil. Plants need to be able to extract them. The nutrients can't be too deep within the soil, for instance, for plants to be able to reach them. Plants also need to be able to absorb them, so the nutrients cannot be irreversibly bonded to soil particles, for instance. And so I could go on, but when we get down to the basics of what makes an environment optimal, we need adequate amounts of light for plants to produce energy, adequate soil physical and chemical properties, adequate nutrients, and an adequate supply of water at the very basics. So today we're talking about the opposite of optimal, harsh conditions. And all of the images of sites that we have up on this slide represent harsh conditions. They have characteristics such as too much water for plant growth, inadequate soil physical and chemical properties that make plant establishment difficult. And then something else that these sites all have in common that may or may not be standing out to you when you look at the pictures is that they all have some form of contamination. So whether that's soil or water contamination, and those all come together to make these sites harsh. And so something else that these sites have in common is that we have or will be establishing soon in the future, we have established plants and trees at these sites successfully. And we're going to be talking today about some of our approaches for establishing trees at sites such as these that have harsh conditions, opposite of optimal conditions. And so you'll be hearing about some of our work at the Forest Service, as well as Max's work in Philadelphia for establishing trees at harsh sites like these. Next slide, please. So the umbrella that all of this work falls under is phytotechnologies, which is the strategic use of plants to solve environmental problems. And those environmental problems could be things like contamination, like I discussed, what our work, Ron, Ryan, and I, revolves around using trees to remediate contamination, or this could be solving other kinds of environmental problems, such as managing stormwater runoff in urban areas, or managing temperature extremes by establishing tree canopies. Next slide, please. Some examples of phytotechnologies that you might be familiar with, some that are commonly implemented in urban areas include green roofs, constructed wetlands, as well as management of stormwater runoff using rain gardens. And so Max is going to be talking more about few phytotechnologies, including urban tree canopies and green infrastructure. And then our team will be covering phytoremediation as one of the most common phytotechnologies that we have done a lot of work in. Next slide, please. So phytoremediation, just one type of phytotechnology, is the use of trees to clean up contaminated soils and waters. Next slide, please. Zooming back out to phytotechnologies as a whole, there are a range of benefits that these plant-based systems can provide, no matter where you're located, no matter what your objectives are. Tree-based systems can provide benefits from the short to the medium to the long term. In the short term, plant-based systems can provide enhanced aesthetics to degraded sites. In the short to medium term, plant-based systems can also provide improved mood, lowered stress, improved psychological well-being. So there's human health benefits too that we're receiving from these plant-based systems. And then in the medium to long term, tree-based or plant-based systems can provide benefits such as improved soil health, noise reduction, improved air quality, erosion control, and then getting into the longest term, carbon sequestration and pollution remediation. Next slide, please. And just to give you a quick visual on some of the examples of different phytotechnology applications. So first, we have pollution mitigation, like we talked about, phytoremediation. This can occur at landfills or riparian buffers when vegetated buffer strips are planted along streams or rivers in order to intercept agricultural nutrients or pesticides or herbicides. Next, we have stormwater management. And so in urban areas, this can take the form of rain gardens, constructed wetlands, bioswales, green roofs. And then phytotechnologies can also be used to improve human well-being. So those benefits that I was mentioning on the previous slide, urban trees and urban forests not only provide benefits such as pollution mitigation and stormwater management, but they can also improve our mood. They can improve our psychological well-being at the same time. And then finally, trees and plants can be used to restore degraded lands, such as mines or brownfields. Next slide, please. And so phytotechnologies are relevant across the rural to urban continuum. And the benefits that they provide, that I was telling you, the ecosystem services, are relevant no matter what your objectives are at a particular location. So no matter if you're trying to manage stormwater or if you're trying to manage contamination, the benefits that these tree-based systems can provide are consistent, such as improved soil and water quality, or management of excess water, or providing shade and cooler temperatures beneath a tree canopy. Next slide, please. And so I'm going to pass the stage to Ron now. He's going to talk about the important step that occurs before we establish trees at harsh sites, and that step is species selection. So Ron, the stage is yours.